A little bit more on slope. If I have a graph of a line or a line segment, what's the formula I can use to find slope? What were the two words we used? What over what? Really? Almost. You're on the right track. Is that run? What is that? Rise over run. That's if you have the graph. If you don't have the graph, if you just have points, this is when you take the 2 points and you subtract the second y coordinate from the first one over the second x coordinate minus the first one. Okay? So this is if you have a graph. This is if there's no graph. Okay. So we got 3 lines. Just by looking at these 3 lines, what's the first thing that comes to your mind? What's the relationship? They're parallel. All right. Let's find the slope of each line. So we're going to find the slope of line 1, slope of line 2, and slope of line 3. I've given you some points on each line. We've got the graph, so let's use rise over run. What's the slope of L1 using these 2 points? How much do you rise and run to get from one point to the other? How much do you rise here to get from this point to this point? How much do you go up? Come on. How much do you go up to get from this point to this point? 3. So I'm here. How much do you run? 1. So the slope of the first one is 3 over 1, or just 3. What about the second one? Do rise over run again. What do you get? 3 over 1 again. Or just 3. Do the third line, line 3. 3 over 1. So what can you tell me about the slopes of parallel lines? They're all the same. They're all equal. So parallel lines have equal slopes. Always. So if you find the slope of one line, and it turns out to be 1 over 3 or negative 2 over 5, and you're asked to find the slope of a parallel line, it's the same. This one. What do you notice about these 2 lines? What would we call them? Remember the name. Perpendicular, I heard. Why? What does perpendicular mean? They, yes, at. They cross at 90-degree angles. Excellent. So they are perpendicular. like we did with the last one. So let's find the slope of each. So let's find the slope of line 1, the slope of line 2. So line 1, this one. I've got 2 points on the line here. How much do I rise to get from this point moving to this point? 1. How much do I run? 2. So the slope is 1 over 2. Line 2. Let's go from here to here. How much do I rise? But I'm going down. -2. How much do I run? 1. Or we could just say -2. Can you see a relationship between these two? What happens? Flips? Does it do anything else? Changes from positive to negative, right? So if I find the slope of a line perpendicular to this, I have to flip it and change the sign from positive to negative. If I find the slope of a line perpendicular to this, to flip it, change the sign to positive. So we would say the slopes of perpendicular lines are negative reciprocals of each other. So you have to do 2 things. You have to flip the number, find the reciprocal. And you have to change the sign. If it's positive, change it to negative. If it's negative, change it to positive. So that's really it. Let's look at a few examples. Here you're given 3 lines. And you're not given the graphs, but you're given 2 points on each line. And you're asked to find, are they parallel to each other? Or no, are they parallel to each other? So what would you have to do to see if they're parallel? Sorry? What are the same? Yes. So we have to find the slopes of each. Okay? So we have to find the slope of GH. We have to find the slope of JK. And we have to find the slope of MN and then see how they compare. So remember, here's where we're going to use the slope formula y2 minus y1 over x2 minus x1. And I'll just write that as a reminder. I won't write it on it. So let's call these ones x2, y2, the second ones. The first one's x1, y. So I get second y is -1 minus first y is 2. Divided by second x is 2 minus first x is -4, so that actually changes to plus. So what do I get when I simplify the top and bottom? -3 over 6 or -1/2. So if they're going to be, if these lines are going to be parallel, their slopes have to work out to -1/2. So let's look at JK. Second y3 minus first y7. Divide. second x 7 minus first x negative 1. And that changes to a plus because it's subtracting the negative. That gives me negative 4 over positive 8, which reduces to negative 1 over 2. So what can you tell me about the first two lines? They're parallel. Because they have the same slopes. Now I just have to check the third one. Second y1 minus first y5 over second x5 minus first x negative 4, which changes to plus. That gives me negative 4 over positive 9, which does not reduce. So we can only say that these two are parallel. They're not all parallel. Okay, second example. We've got two lines, PQ, and given 2 points, RS given 2 points, and we're asked to find if they're parallel, perpendicular, or neither. How would you find that out? What would you have to do? Find the slopes. So I want you guys to go ahead and find these two. You should be comfortable using the slope formula. Okay. So PQ will be 10 minus 2 over negative 2 minus negative 7, which turns out plus 7. So that gives me 8 over 5. RS, second y1 minus first y negative 4, turns out to be plus, over 5 minus 3. Which gives me 5 over 2. Yeah. Thank you. It should be 5 plus 3. So, parallel, perpendicular, or neither? Neither. They're not parallel, it's not the same. They're not perpendicular because one has to be negative and one has to be positive. So, neither. And we could confirm that if we graph them. So if we did negative 7, 2 for P, negative 2, 10, 4, 6, 10 for Q, and R is negative 3, negative 4. So these are lines, not segments. And S is 5, 1. Well, we can definitely see they're not parallel. And they will cross each other eventually. Like somewhere down here. But not at 90-degree angles. Okay. Okay. Couple more. I think you should be able to do this one. So give this one a shot. Okay, so we obviously have to find the slope. Yeah. And that slope is going to be second y -1 minus first y 3 over second x -4 minus first x 2. That gives me -4 over -6, which simplifies. Two negatives become a positive, and I can reduce it to 2 over 3. What would be the perpendicular slope? -3 over 2. And here's a way you can write, so you don't have to write perpendicular all the time. Do an upside down T. That stands for perpendicular. So I could just say perpendicular slope equals -3 over 2. Like so. Okay, the last one. Last one we gotta remember our four-sided shapes. We are told that this figure on the graph is a parallelogram. Do you remember what a parallelogram is? So the opposite sides are parallel, yes. Okay, they're also equal. And if we take a parallelogram, normally a parallelogram looks like this. If we took a parallelogram and moved everything to 90 degrees, we'd get a rectangle. The opposite sides are still parallel, and the opposite sides are still equal. The question is this one, you're told it's a parallelogram, but is it a rectangle? And you can't go by the way it looks. Okay? Because there could be a really slight bend to it. You just can't see it. So we have to prove it. How would we prove it? Well, if I can prove that one of these is a right angle, that means they all must be. Okay, because I'm told it's parallelogram. So if one of them becomes a right, they all have to become right. So I just have to prove one. So what does that mean? I got to prove that this is perpendicular to this. So that means I can use slopes. So if I found the slope of AB, which I can do by rise over run, because I'm given the graph, and if I find the slope of BC, and if they're negative reciprocals of each other, it's got to be a rectangle. So we can use rise over run. So A to B, how much do I rise to get from A to B? -4. How much do I run? 1. So -4 over 1. I'm going to leave it as a fraction because I want to compare it to BC. How about BC? How much do I rise to get from B to C? 2. And then I got to run 8. And that gives me 1 over 4. Are they perpendicular? Yes, because they're negative reciprocals. So I've proven that the slope of AB, and I'll use math notation, is perpendicular to the slope of BC. Therefore, ABCD is a rectangle. Oh, inverted. Wait. it's not gonna go away. All right,